My last name's Davis,
My last name is Johnson.
and together we're both Nathan.
Nathan.
Our project is Give Me One Reason to Stay Here. The goal of our project is to find the 10 best cities in the U.S. to live in. Within each city, we're going to look for the best places to live within that city. The cities from our list that we got are first, Austin, Texas, Boise, Idaho, Boulder, Colorado, Charlotte, North Carolina, Kansas City, Missouri, Omaha, Nebraska, Portland, Oregon, Raleigh, North Carolina, San Diego, California, and San Francisco, California.
Here we have the city of Austin as an example. I've put a boundary layer on there that you can see, and this is actually the urban boundary rather than just the city boundary. And we felt that was important, so we can include anything that's urban around Austin. Here are the airports, and we want it to be a little bit further away from airports so that the noise didn't distract you. And here are the Walmarts. There are a lot of Walmarts, but we wanted to be pretty close to a Walmart but not right next to it, because who wants to live right next to a Walmart? I mean, come on. And we have two varieties of steakhouses. In our culture, steakhouses mean two things. You have your churches, steak centers, so you have your religious organization that you want to be near. And you also have steakhouses, such as Outback Steakhouse or Texas Roadhouse. These stars represent all the Outbacks or Texas Roadhouses in Austin. And we want to be, of course, close to steakhouses and close to churches.
The data that we've used is also customizable once you understand what's being done with it. Anything that you wanted to be far away from, you could substitute for the airport data. Things you wanted to be close to, you could substitute in church or steak. And things you wanted to be close to but not right next to, you could substitute in the Walmart values.
Here's an example of how we found a lot of our data. Initially, we would usually do a Google Maps search and then georeference those images, but that got pretty tedious. So we found a way around that using Google Earth. Here we have Austin, and I'm searching for Outback Steakhouses near Austin, Texas. And you see that it found 3 results. Now, rather than georeferencing this data, we can actually take it directly into ArcMap by saving the search result as a KML. And this is done in 2 steps. You first save it to your places, and here it is in My Places. Then you right click the folder and save place as, and then it's defaulting to the search you made. So you have Outback Steakhouses near Austin, Texas, and you can save that as a KML file to any place that you want. And then you can take that KML file and import it into ArcGIS, converting it to a layer, which then you can convert to a shapefile. So it's actually a very easy and convenient way to find these the data that we needed for the 10 cities that we had.
When you receive the folder that the Python script is in, you'll notice that there's a folder cities that contains data for each city, the Give Me Python script, One Reason template, and the toolbox. I'm going to go ahead and open the One Reason template and show you what that contains. Here you'll notice we've set up just a basic template. Right now it's set on Austin, Texas. There's a title of Give Me One Reason to Stay Here. The city for the current map. That'll change each time you loop through a city. Here's a map, and right now we just have the boundary layer on, showing the area around the city. A scale, a name, date, projection. You can change this name here so that it'll show up which name you'd like. Page number 1 through 10, and this legend will populate as it goes through. As far as how your data needs to be set up, the folder that you have the data in will be considered the root folder, and before you run the Python script, you'll be able to set which folder that should be looking at. It's important in there that you have a folder named cities and 10 cities within that cities folder. You'll notice here we have Austin through San Francisco, California. Each city should have the same named data. There should be an airport shapefile, a boundary shapefile, church shapefile, stake shapefile, and a Walmart shapefile. It's important that they're all named exactly like this. You'll notice if you look at this data in the Windows Explorer that there will be multiple files, but it's important that they're each named with this naming convention. Each of these 10 cities has that data. These two layers, the boundary and final raster, are used to apply symbology to the template as it runs through each time so that the colors and symbols will be the same throughout the atlas that contains the 10 cities. The toolbox here will have the script. We'll talk about that a little bit later, and then you'll see the template. The final piece of data that you need to be sure to have in your cities folder is this freeway shapefile. This contains all of the freeway shape data for the entire country so that you don't have to get that for each individual city that you decide to analyze. Once you're ready to run the script, you'll expand the toolbox and there will be the script. You double click on that and you'll see the settings that you have to work with. You're able to set the root folder. This is where all of your city data should be contained. And then you'll notice that we have several buffers. Each of these buffers is in miles, so it's important to keep that in mind. The airport buffer is 4 miles for our example here, and that's meaning that we want to be at least 4 miles away from the airport. The church buffer is also 4 miles, but that's the opposite meaning we want to be within 4 miles. Stake buffer, we'd also like to be within 5 miles. Walmart has 2. The min is the minimum distance you want to be away from Walmart, so for us that's half a mile, and the max is the maximum distance you want to be, so 5 miles. So in this example you want to be more than half a mile but less than 5 miles away from a Walmart. Similar idea with the freeway. You want to be at least half a mile away, but want to be within 4 miles of the freeway. When you're ready to run, you'll press OK and it'll run you through the script. Before we get into the Python script, we wanted to show the model that that's based on. You'll see here that we have each of our data sets that's projected into the correct projection. A multi-ring buffer is then applied, and we have our buffered data. That data is converted to raster and reclassified. Each good value is assigned 1 point, and each bad value is assigned 0 points. Once we have that data, it's put into the raster calculator and added together for a final value. We then extract by mask based on the projected boundary, and we're given our final value.
Here's our script which does the geoprocessing and the map creation for each city. The arguments for the root directory and buffer links are assigned to variables which are referenced later in the script. And then a temporary directory is created and a geodatabase is created to store all of our intermediate data. Before we dive into the loop, an atlas is created which will house all of the final PDFs for each of the 10 cities. Let's dive into the loop. The loop iterates over each file in the root directory. The first part of the loop checks to see if the file is actually a directory. This is important so that we're only processing on city data. Then the workspace is set to the working directory. This is important down in the local variables section so that we can just reference the airport data for the current city. Here's where we start our geoprocessing. First, we project all the data into a common output coordinate system. The freeway's data is clipped to the boundary of the city and then projected. Here's where all those buffer arguments entered by the user work their magic. Before they can be combined into a single dataset, they are converted to a raster and then reclassified. Let's move down to the reclassification section here. The areas of the city that we don't want to live in are assigned to 0. And the areas we do want to are assigned to 1. So in the case of the airport,
Areas directly around the airport are assigned 0, and areas outside of that buffer are assigned 1. You'll also notice that the extent is reset for each reclassify. This is to prevent ArcGIS from crashing as it runs through the script. These sleeps right here are also to prevent crashing. Now that the data is all reclassified, it's ready to be put into the raster calculator. All the raster calculator does is adds up each of the 5 data sets. The final raster contains values between 5 and 0, where 5 is the most desirable place to live and 0 is the least desirable place to live. We then add that to the map, apply common symbology from the layer files, and then we do little things like change the title of the text, set the map extent, and refresh the view. Finally, a PDF of the city is created, and the PDF is appended to the atlas. To clean up for the next iteration, the layers are removed and the view is refreshed. After all 10 cities are added to the atlas, it is finally saved and closed, and the script completes.
Once the script is run completely, you can open a Windows Explorer window. Go to your root directory, you'll see a Final 10 PDF. This contains the results of the script. If we open up this PDF, you'll see that there's one page for each city. Give me one reason to stay here for Austin, Texas. You can see there's the urban boundary outline, as well as a value. Green being 0, red being 5, with a scale in between. 5 being the most desirable area in the urban area to live in. You can see that Austin has quite a few areas that are desirable. You can also see at the bottom we have page numbers 1 through 10. As we scroll through, you'll see Boise, Boulder, Charlotte, and you'll notice that some of these cities have more red areas than others do. Kansas City, Omaha, Portland, Raleigh, San Diego, and San Francisco. You can see as we scroll through this that each of these have the same symbology, meaning that green is 0 on all of the maps and red is 5. This is the importance of those symbology layers that were contained in the file that you obtained with the script. This has been Give Me One Reason to Stay Here, presented by Nathans Davis and Johnson. Thanks for watching.